plus x cubed 1 plus px to the power 4. So for this we need, we're interested in coefficient of x, especially coefficient of x squared and maybe coefficient of x to the power 7. So we know what this is. That's Pascal triangle. This is 1 plus 3x squared, right? X cubed. Now this is 14641, right? 4 power 4. Yes. So it will be 1 4px 6p squared x squared 4p cubed x cubed then p to the power 4 x to the power 4. So that's the 2. But we don't need to expand everything out. We need coefficient of x. To get coefficient of x, it will be constant times coefficient of x, then coefficient of x times constant. So for coefficient of x, actually we have the constant too, right? Well, constant and constant is 1, so that is irrelevant, right? But if you look at when this multiplies this, and when this multiplies this, you get your coefficient of x. So if you do that, 1 times 4x will be 4, 1 times 4px will be 4px, 3 times that will be 3x, right? That's on the left, and on the right, what's that? Qx, right? Did anybody get that? Okay, so this means you have what? 4p plus 3 is equal to q, so that would be useful at the point. Now for the square, how do we get square? You need, for square, you need a constant times square. Constant times square, that's p, 6p squared x squared. You need x and x, right? X and x, what do we get? 12px squared. Then you need the square term times constant. So it's like this is moving forward, this is coming backward. What is that? 3x squared. Leo, you're still not saying anything. Whether you understand or not, I don't know. If you understand, you're supposed to repeat those things after me and not just look. This is, I don't know. You're not helping yourself, young man. So, when you combine all these, you get 6p squared plus 12p, right? Plus 3 equals 93, right? And we can form a quadratic equation. 6p squared plus 12p minus 90 equals 0. So you can divide by 6. Can we divide it by 6? Yes. 15. So you have p squared plus 2p minus 15 equals 0. 15 would be 5 and 3. P minus 3, p plus 5 equals 0. So p equals 3, or p is equal to negative 5. Now, what are we looking for? Possible values of p and q. So you come back here for q. Since q equals 4p minus plus 3, when p is equal to 3, q will be 4 times 3 plus 3. When q is minus 5, q is 4 times minus 5 plus 3. So here, q is what? 15. What? 15. And here q is negative 17. We got that. Alright, so that should be it. So the other one I sent to the WeChat group is this. So this is the second I sent to the WeChat group. Are you on number 3 already? Good. Uh-oh. I thought I sent it to the WeChat group. Did you guys see this? That's number 2. Or was that my number 3? Why is Clarissa's message saying otherwise? Did you see that? Okay, great. So take a picture of this and send to the book later if somebody wants it. In about 5 minutes, I will ask you to stop so that we look at that number 2 also.
Only sent 3 questions, right? You should not know. Only 3 questions, right?
What do you mean?
You have it.
Yeah, only 3 that I put there so far. So A is not a problem, so we don't need to waste time. I'm just going to go ahead and write that while I wait for your B. Did you get that? What's your A? It doesn't matter which one comes first, as long as these are the 2 linear factors. Whether your x plus 2 is the second bracket, it doesn't matter. So let's see. I just want to know the technique we might be using here to get the coefficient of x to the power 9. Continue your work.
You give me an answer for this question.
What?
You give me an answer for this question.
Do what?
You give me an answer for this question.
But that's not number 2, right? You finished 2, okay. Well, you only have first two, right?
Yes.
Expand this fully, then
Wait.
do what we did.
Expand this.
Expand the first one fully,
Okay.
and this just expand up to the second term. There is something on 1 plus NB. We did a binomial expansion 1 plus NB. It's 1 plus b to power n. We use it to expand fractional stuff, right?
No, but the thing is that you don't know if this is a function.
I know. Okay, think of this as you want to expand the binomial whatever. Even if you use the binomial theorem, there will be summation NCR A n minus R B R, right? So your A is 1. So this is simply summation NCR B to power R, because your A is 1. So expand this up to the second term. When R is equal to 0 and when R is equal to 1. Because you only have in that question power 1, x to power 1. So you just do R is equal to 0 and R is equal to 1. What was that bracket again? 1 plus what?
5 plus nx squared.
Oh,
That one. 1 plus 3 over 5x.
3 over
5x.
x beside it
Yeah.
or below.
Beside.
So this is your B. So substitute in there. So expand up to the second term only, because you only know the quotient of x. Understood? It's similar to what we did on the board here. What we did here. You have two brackets. One is expanded up to linear. So you don't know beyond this point for this question. But here you know everything. So you now begin to check. How do you get x to the power 9? Where do you get minus from? No, this is what you are using. What are you saying?
Oh, okay.
Done? Which one is that? Okay, can I say the second one? Okay, continue. How about 6-3? Down to 6 again. So you have 4, 5, 1, 5, 4. So you can use R term to okay, I was telling him to actually go this one. Alright. So we look at this now. So, hence or otherwise, I'm referring to this question now. Hence or otherwise, we want to find the coefficient of x to the power 9 in the expansion of 3x squared plus 5x minus 2 to the power 5. We want to know the coefficient of x to the power 9. So, because we have done this, you can put this together. So that is simply x plus 2 to the power 5 and 3x minus 1 to the power 5. Yes? Right? So in this expansion, you need coefficient of x to the power 9. So you don't have to expand everything fully, 6 times of this, 6 times of this, and begin to do that. It's because this is like a short one. There is power 3. So it's easy to just write. But you don't have to write power 5. We have done this before in the class where we consider what are the possible scenarios for getting x to the power 9. So you can either have a constant and power 9, there's no 9. You can either have power 8 and power 1, there's nothing like that. Okay? 7 and 2, there's nothing like that. 6 and 3, there's nothing like that. 3 exists but 6 does not exist, so it technically doesn't exist. So you can have 5 and 4, right? And 5 and 4, 4 and 5, that's all. You can't go below that, right? So which means x to the power 4 here versus x to the power 5 here, and x to the power 5 here versus x to the power 4 here, something like that. No, 5 here, 4 here, 4 here, 5 here also. So, if you can imagine it, fine. Otherwise, you can use your R term, R plus 1 term. Remember, we did R plus 1 term a while ago. R plus 1 term is n combination R a raised to the power n minus R b raised to the power R. Agree? Remember this? So we can use that. So with that, for the first one, if I use it on the first one, okay, let's say using R plus 1 term, or general term, we also call it general term, right? Alright, let's say general term, because we are not talking about the term this time. This question is not about term, it's about coefficient. So I will just use general term. There are two words we use then. Either we call it general term or R plus 1 term. The case, let's clarify. The case when you can call this R plus 1 term is if the question is talking about find the third term in the expansion. Find the fourth term. So the question is on the term. then you can call this general term formula r plus 1 term. Okay? I hope you remember what I'm saying. So using general term of the binomial to be n that. So if we substitute for the first one, so the general term for this one, is what? So that is n is 5, combination r, a is x. So x to power what? 5 minus r, then 2 to power r. That's for the first one. And for the second one, 3x minus 1 to power 5. What is the general term? Yes, somebody talk to me. 5 combination r, 3x to power 5 minus r, then negative 1 to power r. So those are the two general terms. Okay? Alright, so here we will consider when the power is 4 and when the power is 5. Here we consider the same thing. So the 4 of this times the 5 of this. You get what I mean? Okay. So when is this power going to be 4? That's when r is equal to 1. Okay? When is this power going to be 5? When r is equal to 0. Right? So, first one, we can say when r is equal to 0, then you have, so let's just deal with the coefficients. Okay? So when r is equal to 0, we get coefficient of x to power what? X to power 5. Right? Coefficient of x to power 5 will be 5 combination 0. You don't need the x anymore. Times what? 2 raised to power 0. Hello? What is 5 combination 0? 1. 2 raised to power 0, 1. So the coefficient of x to power 5 is 1. And that makes sense because look at it. That's the first one. So when r is equal to 1, when r is equal to 1, that's when you get x to power 4 term. Right? So coefficient of x to power 4 is 5 combination 1 times 2 raised to power 1. 5 times 2, 10. Is that? Okay? Well, you may not break it down this way, but make sure you explain. So for the second part, this is for, I should have written for 3x to power, sorry. This is for x plus 2 to power 5. Okay? Now, for 3x minus 1 to power 5, based on this general term, I think the same thing applies. When r is equal to 0, you get x to power 5. And when r is equal to 1, you get x to power 4 term. Understood? But then, this needs to probably be simplified further. Because our x is not standing alone. So if you remove x totally, 5 combination r, 3 to power 5 minus r, negative 1 to power r, followed by x 5 minus r. Understood? So if we are talking about the coefficients, we are talking about this only. Okay? Alright, so for this, when r is equal to 0, when r is equal to 0, you'll be dealing with x to power 5 term. Okay? When r is equal to 0, coefficient of x to power 5 will be what? Talk to me, please. When r is equal to 0, coefficient of x to power 5 will be what? 5 combination 0, 3 to power 5, negative 1 to power 5. Is it? No, 0. So this is 1. This is 2, 4, 3. Yes? And this is 1 also. So you get 2, 4, 3. Then, when r equals 1, you'll be dealing with coefficients. Well, my spelling is horrible, so just leave it like that. Coefficient of x to the power 4 will be what? Yes? 5c1, 3 to the power of what? 4. Negative 1 to the power 1. So that's the negative term. This is 5, 81, and negative 1. What's that? Negative 405. So what exactly do we need? We need 5 here and 4 here, right? Then we need the 4 here and the 5 here to get x to the power 9. Okay? So therefore, coefficient of x to the power 9 will be 5 in the first one times 4 in the second one plus 4 in the first one times 5 in the second one. Right? And what is that? 405 minus...
Wait, is it 242?
Okay, sorry. Is this one? This one?
Yeah, this one. No.
243. Okay. So, this one? Plus 2430. So what do we got? Final. 2025. Like that? I hope the idea is well understood. We have done this numerous times just to remind ourselves. The third question, I believe you have made some attempts. Let's look at that also.
Yeah, that's time for that though.
Is it time already? Yeah, almost. No time yet. Which one is the third one that I sent to the group? Is it this one?
It's okay.
Yeah, this is the third one. Brandon, can you focus on this part for me, please? How many more minutes do we have? Uh-oh.
That's what I meant, Mr. Jackson.
So, what do you do here? For those that have done it, do you expand this to get quadratic?
Yeah.
So if you expand this to get quadratic, Brandon, can you check if you're here? Is what? Is okay?
It's okay.
Alright. So you expand this to get quadratic, then that was what I was trying to tell you. If you simplify this up to just linear, it's enough. Because you only have linear anyway. And here, you only need the first two, actually. So it won't take time. And look at it. So,
25.
what?
I'm just thinking the example. 25.
You really want to get out of the class, I know. You can leave if you want.
No, just make it.
Okay. Mr. Lazy Man. Because I don't want to come back to this for the second session, so if I may just finish what I'm doing. This,
25.
you got 25, yes?
10,
10 and x,
n squared.
n squared, x squared. Now for this part, I want you to remember from a plus b to power n is n summation, right? N combination r, a raised to power n minus r, b raised to power r. If a is 1, if a is 1, 1 plus b to power n simply becomes n combination r, b raised to power r. Okay? And you only need for r is equal to 0 and r is equal to 1. Okay? So basically this is simply summation r equals 0 to n combination r 3 over 5x to power what? R. Does that make sense? So which means whatever this is, this remains the same. Then this is just for the first two. When r is equal to 0, you have n combination 0. When r is equal to 0, this bracket is to power 0 also, right? That's just 1. Because anything combination 0 is 1. So this is 3 over 5x. Now when r is 1, n combination 1, then 3 over 5x to power 1, and the rest is summation. Okay? That's what we use. So this same bracket, this is 1. N combination 1 is n, remember? So n times this will just be 3 over 5 nx. And the rest continues. So if you already have 25, 10nx plus n squared x squared, and you only have the first two, right? Only linear. So the linear will multiply, get 25. No, the constant will multiply. Then to get the linear parts, well, which means we don't even need that because this is just repetition of what we know. So we multiply this by this, 25 by 3 over 5 nx plus this by this. Hello? Which is what? 10 nx. And the rest, we don't care. Just put continuation because we are not approximating, right? So that is 25 plus, what is this? 15 nx, yes? Plus 10 nx. And we continue. So if you compare both sides, if you compare with this, that will be what?
Wait,
so compare,
15 and 10 first.
compare with the right hand side, we have what? 25 nx to be equal to 100x. So and n is equal to 4. Okay? So let's go for break. Oh no, actually you have a class. Then we come back for the class session.
Okay, 俾翻你。